Let me get straight into it. Data interchange. It's a fun topic. For background, this is actually a topic that I introduced years ago into Comp 1531, and it's very boring. And to some extent, it's one of those things that a lot of people just kind of learn like on the go because it's not very hard. But we figured that it would be good to formally introduce it in, if that makes sense. Just so people have a little bit more context around it. But before I keep speaking so vaguely about this, data interchange topic, let's actually like unpack it. So with systems, we need a common way of communicating between different operating systems, servers, and programming languages, right? You think about it: Java, C, C++, JavaScript, Python. You've got Windows, Mac, Linux, different kinds of web servers, different applications. Like there's a lot going on in the world that's very, disconnected. Even like you think about it, like in front of me here, I got my phone, I've got the webcam, I've got a camera, I've got headphones, I've got a dead phone that's years old, I've got speakers, and this microphone. They're all different, but they somehow talk to this darn computer in front of me, right? And that's kind of at the core of like, well, we need that naturally, but like, how does it work? And we're going to be talking through standard interfaces, which is the concept, and then into JSON, YAML, and XML, which are three different types of interfaces, I guess you would say. So firstly, what is a standard interface? Such a fun question, isn't it? What do you think of when you think of a standard interface? Interface, I think, is a word. I won't wait for the how old's my dead phone? 2020. I don't know why it's just sitting there. It's just been sitting there for years. It's like very broken. Yeah. I don't even know why the back of the camera's off like that, but anyway, it's probably time. When people think of standard interfaces, I think they jump to use screens a lot because interface often implies like app or GUI or something like that. But I think the way to think about it is it's like, what's the way that any two things connect to each other? Some examples are like bolts. I really like bolts as a good example because like what I think is easy to forget is like there's kind of just a size of bolt. There's sizes of bolts. Like there's like a 4mm bolt, a 5mm bolt, and then there's the imperial bolts. And all these different people can connect all these different things together just by using a series of bolts. So when someone's like, hey, I have a thing, you have a thing, let's connect it together. All you need is like a 5mm bolt. Everyone's like, we know what 5mm bolts are because they're a standard interface of how we're going to work with, bolting and fastening stuff. Got a few mechanical throw-ins for our mechatronics students. Hello. Websites, we're kind of going to talk about this next week, so let's not talk about it now. Railway tracks is always interesting. I always love talking about this because, when you make different trains, they typically work on certain sets of interfaces, right? Cars are like this too. Like everything is like this if you pay attention. There's certain rules and guidelines, wheel sizes, tires. How come you can take a tire off your car and put it on your friend's car a lot of the time? There's maybe like, 4 or 5 different general sizes of tires, but like that's pretty crazy because someone sat down and was like, here's the standard interface that we're going to work to and we're going to make things work like that. They are everywhere in reality. Cans have standard interfaces. You can stack a Coke can on a Sprite can. I should be careful here because, I'm using the term standard interface, but what we're really talking about there is standards, right? But the reason I say interface is because, a standard is just a rule about how something needs to be. Like there might be standards for buildings, fire safety, stuff like that. What I'm talking about with standard interfaces is whenever there's standards that relate to multiple things having to work together. So the fact that you can go make 2 trains and they run on the same set of rails, the fact that you can go make different equipment and they can use the same bolts, the fact that, I don't know why there's an image missing there, but USBs are like a really great example of standard interface. How all these devices talk together is that someone came along at some point, this is a new USB-C, and they were like, well, that thing, it's going to work a certain way, it's going to be like that, and lots of different people are going to work with it. My phone and my headphones are USB-C. This camera I'm using here is USB-C. Lots of things are USB-C. So that's basically what a standard interface is. And what do they all have in common? They're universal methods of connecting different types of systems together. Because we often take for granted headphones and phones are very different things, but they somehow just work seamlessly together. The point of this lecture, though, is not to talk about railway tracks or USBs or bolts. It's to talk about standard interfaces for data. Because in the world of software, we actually have standard interfaces for how we transfer and store data between different applications. A really good example of that is what would happen if C wanted to output something and share the results with the JavaScript program. How would you do that, right? C doesn't understand JavaScript. Node, if you gave Node some .c code, it would just crap it out. And if you gave GCC some JavaScript code, it would also crap it out. So what are we going to do about that? Well, we need a way to standard interface do that. And what we often talk about when it comes to data is what we might call a data interchange format. That's why the name of this lecture is Data Interchange. But regardless, I would probably encourage you just to think about it as data standard interfaces, right? Because data interchange is, the more I talk about this, the more I'm kind of like, I don't know about the exact way to describe it, but think of it like a standard interface for data. That's what we're talking about today. You might also refer to that as a data interchange format. And the cool thing about this concept is like, you don't really need to like think too deeply about it, because like even if I didn't have this today and I said to you, how would you do this? You'd probably tell me one or two things would be the most common answers. I'll just store it in a text file, or maybe I'll store it in a CSV, right? Because they're two formats most students are very comfortable with. And the cool thing about text files and CSVs is they're quite literal. Whereas, other formats like PDF or XLSX or .doc or something, like if you try and open those, they're not really like written in plain text. So, text files, you get it, right? Like you have a C program, it outputs text and you go, oh, cool. Great. JavaScript can read text, C can output text, they can both talk to each other. But the problem with text files is a text file is what I would call an unstructured interface or an unstructured data interchange format. What I mean by that is there's no structure to it. And for things to be good interfaces, they need to have structure. And what I mean by that is like, again, you think about it with like railway tracks. It's like if you have 3 or 4 different types of trains in Sydney that are all trying to work on the same tracks, it's like it can't be enough to say like, oh, the interface is just tracks. The interface needs to be something that everyone agrees on in advance so they can plan for it. There's a defined structure to it. So we need some kind of structured interface. And text files are not structured interfaces. However, what would happen if I said to you, no, we're going to use like text files. However, there's going to have to be certain rules to it. And those rules might be like every line has to be a new item in a list. So if I've got a list of 3 things like this, that's the structure. So every line is an item in a list. So if C does some stuff and it outputs, for instance, a list, put it in a text file, 1 per line. And then someone comes along and says, yeah, that's cool, but what if we want to have like structs or dictionaries or objects, depending on what you call it? And you say, okay, well, yeah, on each line, I guess, instead of, either we have that, or if we have a funny little syntax where we say, name is Hayden, like this, And someone's like, yeah, okay, cool. That makes sense. So then we have like, here's a list of 5 things where the first 4 are just stuff. And the last one is like, an object of some sort. And then someone says, cool, but then what happens if someone puts this down here? Is that the number 0 or the string 0? And then someone goes, okay, well, maybe the structure of this interface, we should use double quotes. And the double quotes are going to help us understand the difference between something that's a string and something that's a number. Because now that's a number and this is a string. Each line's an item of the list, right? And what that would do, if you started to add structure to that, is you would end up with a data interchange format or a standard interface for data, like one of the 3 things we have here. And that's what JSON, YAML, and XML are. They are the primary interfaces for exchanging kind of information between things. And there's going to be more than this out there, and so on and so forth. And there's very use case specific ones, like, the way queues are absorbed in queue-based cloud services and stuff like that. So don't get caught up thinking that this is the holy trinity and that's the end of it, because it's definitely not. But we're going to talk about JSON, which is probably by far the most popular one for application builders out there. So JSON stands for JavaScript Object Notation. The hilarious thing about this definition is that it has nothing to do with JavaScript. It just so happens that the guy, last name Crockford, who set up the standard originally, can't remember was it Richard? Was it Crockford? Douglas, not Richard. Douglas Crockford. He also has been quite involved in JavaScript. I don't know why they call it JavaScript Object Notation, but I mean, I guess it's a little JavaScript-y, but it's not like they're like linked is the main point, you know? It's kind of like, you know, lots of things. I was trying to think of an example. It's like Yamaha, you know, they make pianos and they make cars. I'm sure they have some overlap, but, you know, might as well not be that related. Not really the end of the world. So JavaScript is a format made up of braces for objects, square brackets for arrays, where all non-numeric items are wrapped in quotations. And it is similar to JavaScript data structures. So that's where you can kind of infer the name from. This is what JSON looks like. Super similar to JavaScript in the sense that it kind of has a similar structure. There are some absolute differences to it though. For instance, like you can't have trailing commas, object keys must be included in apostrophes. You can avoid that in JavaScript. So for instance, if I took this in JavaScript, it's not quite the same because I could, oh, goodness gracious. There we go. Yep. In JavaScript, I could do a few things differently. I don't need quotations around object keys, so I could get rid of all of those like this. I also could have trailing commas at the end. So after postcode, I could go and do this. I also could, if I wanted to, replace the double apostrophes with Jesus Christ, double apostrophes with that. So, you know, there's some similarities, but it's definitely, don't treat it as a one-to-one with JavaScript. I'd say the best way to imagine it is it's like JavaScript with a lot more rules might be how to think about it rather than the other way around. But that's what it looks like. That's how you write it. You got to think of it like a text file, right? Because it is just stored as a string. And that's the cool thing about JSON. It's just basically like ASCII UTF-8. It's just a text file that happens to have the text.json at the end of it, right? And that's kind of all there is to that. Most languages have capabilities either built in or via libraries to write and read JSON. So as an example, Python has a very small library that you can include or import called JSON. JavaScript has a built-in way to manage it. JavaScript is probably one of the only built-in ones. Probably again because it's come from a similar author, so like those two things would have been tightly coupled. What I was saying before, because I see some commentary in the comments, when I was like JavaScript and JSON aren't that related, what I mean is not that they literally aren't related or have common people working on it. What I'm saying is like you can use JSON to make a C program talk to a Java program. Perfectly fine. They can share results. You don't need JavaScript in the picture at all to make good full use of JSON in the slightest, and I think that's an important note to point out. So yeah, most languages have that capability. Most of the time, these libraries are responsible for converting between the specific language data structure, that should say, and a stringified or text-based dump of JSON. What I mean by that is a JSON file is literally like this. It looks like this. That's what packagelock.json is. These are just text files, really. Like it's just text of a particular structure. So you take a text file, you add the JSON rules to it to add structure, and it's now a JSON file. What these libraries that convert between JSON and the specific thing is they allow you to take text in the JSON structure and make it make sense to the specific language. Because the way that, say, Java or Python or JavaScript or C are going to structure those different data types and strings together will be different. So, for instance, if I really simply here have, I might have my like JSON file, right? This is the actual like JSON file. It's just text. Then over here, I might have my, Python and my JavaScript. So I've got a Python file there. I've got a JavaScript file there. And then in between those, they are going to have basically JSON to JavaScript library, which is in this case is built in. And then over here, they might have it's kind of in a weird spot. They might have a JSON to Python library, which is imported, downloaded, you know? And these libraries are what's responsible for helping Python convert its kind of like inner workings to a text file, and then you can take the text file back to inner workings. And that's how they work together. So someone says, what's the difference between a .js file and a .text file? I love this question because I don't know why it just isn't ever taught anywhere, but file extensions are just instructions to operating systems as to how to deal with stuff. The best way to imagine it is that pretty much every file on your computer is binary, right? Naturally, it's going to be represented in some way as binary. However, in general, the way I like to think about it is it's either going to be binary or it is going to be text readable. Doesn't matter what it is. The file extension is just there to tell the operating system generally what to like use to open it, really. So if this file here, .js, .json, it's all just text. It's all just text. It's just the JSON helps the editor know how to format it. If I was to just open that folder in like the file reader, it would guess what program to use. So that's pretty important. But binary stuff is a little bit different too, just to point that out. So if I made a file here called run.c and it just did like nothing, set return 0, and then I compile that, and I was to open that up, it's going to look like this, right? Now, again, obviously the text.c file is a text file. Obviously that has a binary representation, but a lot of the editors we use, because editors are kind of how we experience and understand files, that's in binary too. It just happens that the text editor sees that it's text and is like, okay, cool. Because you could open that as text, right? Like, I don't know, if let's try and change it. If I changed run to be run.txt and then I open it, no, it does. Yeah, it still doesn't know what to do with it. It's missing certain things in the file that help it understand that it's actually text readable. Just reading through some comments because there are some good comments. I recall changing the extension of some files and then changing it back and it is corrupted or something. Is this somehow different? Look, I'm not going to pretend I'm an expert on everything, so I don't know, but generally speaking, changing file types does not change the underlying contents of the file. A couple of things could have happened there. Either the operating system tried to change the file when you change the extension. It could have also just seen the extension change and flagged it as corrupt, even if it wasn't. But yeah, generally it's not going to, do that. How does C convert its data to JSON and vice versa? Because C is way more strict with its data. Well, that's a good question. Frankly, not a lot of JSON conversions to C that go on out there in the world, I'd say. I'd say most of it's kind of dealing with languages like Java and JavaScript and Python. But it's still possible. And the reason is because if you go look at the JSON format, it really doesn't have many types to it. Like if I come back up here, right? And it should say string somewhere. Yeah, like this is it. It's like you got values, objects, arrays, numbers, strings. That's kind of it. So like C, in theory, would be able to make sense of objects as structs. Though that one's a little bit harder because that would need to be like type, compile time aware. So don't get caught up in the C thing. I personally haven't seen anyone trying to deal with C and JSON in any great depth. But the point is that it's theoretically possible, right? Because it's just a common format that's clearly defined. Because to this thing, it's like, how do different languages understand it? It's like someone writes a program, just like Jest, just like anything, where it takes in a string and it outputs in some way something else, right? It's just like compilers in general. It's all kind of the same concept. I'm going to move on a little bit just for a sec here. So, yep, we talked about that. Now here's some JSON code, or some code to create JSON. I think that's really important. So let's open this up, JSON it. Oh, sorry, we're in the wrong lecture today. JSON it, yep. So I've got a data structure here. Now I don't need any of this extra code. I'm going to comment it out for now because it's just a data structure. I really want to convey that point. Let's make this smaller. Okay, so no JSON it. Cool, does nothing because I print nothing, right? But it's just a data structure in JavaScript. It's not anything, super unique. That is the wrong language. Sorry about that. Console log, okay, I get it out. That's JavaScript. This is a JavaScript object that only JavaScript understands in the way it's stored internally, that we happen to print it in a human readable representation. What I can also do, and I think this is really important to understand, is I can also use the built-in JavaScript function to take a JavaScript object or array and turn it into a JSON string. And I think this is important, printing this out. These two things are obviously not the same. This is a string representation of a JavaScript specific understanding of data. This is literal ASCII text, right? That there is what gets given to other people. Because the point is that anyone else, if they wanted to, could take that text and then turn it back into something in their own specific language, or even frankly, honestly, turn it back into JavaScript. Because this doesn't have to just be like an interface method. It can also just be a storage method. In fact, that's kind of what we get you to do in your project, which we talk about in a couple of weeks as well, is that you just use it to store stuff. Like it can interface with itself. It's just a nice, simple, standard format. Therefore, it also can't do everything either. It can only do, certain basic types. However, what I want to do is I don't just want to print it to the terminal. I actually want to open a file called export.json and print it out. I need this little flag thing here to say I'm opening a file and writing to it. And I'm putting the data in a file, and that file is named export.json. So I run that. I forgot to uncomment out file system here. I'll zoom out a bit just so you can see it all and get away from my head. Run that, and there you go. So now it's in a new file called export.json. That's pretty cool. And what I can also do is I have another file here called unjson it, where I can have the exact opposite thing happen. So what I can say is I can read from a file, firstly. So what happens when I read from this file is I will get a string, because all I've done in this case here, if I run unjson it, is, oh, kind of screwed that up a little bit. I think I need to turn that into string. Just let me wrap that in string. See if this solves it. Yeah. So, sometimes when we open files, you can change the settings. I just can't remember off the top of my head. Sometimes big files, they don't try and read in everything at once, because you could imagine if the file's like 100 megabytes, that'll churn up a lot of memory. So what happened there was it wasn't giving me the text. It was kind of giving me like an intermediate structure that allowed me to like consume the text gradually. And I just kind of forced it there and was like, I don't want your buffer. Just give me the text itself. But this is what I read from the file. So I've read that from the file. It's just a JavaScript string. However, the opposite function here, json.parse, it goes and takes that string and turns it into a normal JavaScript structure. So then when I run that, it's like, yep, here's the raw string. Here it is after conversion. So I've managed to take JavaScript object down to a string, into a file, unwrap it into a string by reading the file, and then turn it back into JavaScript code. Yeah. So that's it. It's actually really straightforward. There's not really a lot of like gotchas to do with that. And I went through the unpack it code as well. That's JavaScript. It's JSON. It's really, really simple. It's just strings, ints, decimals, booleans, arrays, and objects represented as a string. And it's so simple that lots of different languages can understand it. It's also commonly the data interchange format that people send over the internet, like send data over the internet. So, your this YouTube video you're watching right now, it will be receiving some data, probably not the video itself, but, data like, maybe the timestamps, or when you click pause and the pause wants to send information to YouTube, it would all be some kind of JSON structure, some information work. Someone says, does JSON.parse work if you pass in that weird buffer format? It's a good question. Let's try it out. Probably. No, yeah, it does. Which makes sense, like, because, people probably do that quite often, so they read from it that way. And different programs have different ways of doing things. Like, if I look up, Python read JSON file, it does it, like, even though you have to import something, it does it pretty elegantly. I think, yeah, it does it kind of like this. It's kind of the same, actually. I don't know why I said that. It's about equally as complicated. Yeah. What about Java? Java read JSON. Java's typed, so I imagine that it's going to be a bit more painful. JSON object. Yeah, I don't know. This is what I mean. Like, it's not like literally universal. Like you'd use it everywhere all the time. It's just extremely common. Generally, unstructured languages will like it more because languages that have explicit typings at compile time might find it a little bit hard to know what to do with it. Like we talked about that with C. So it's more likely you're going to see it in things like Python and JavaScript and anything that's a bit more unstructured. But again, nothing actually stops it being used. And then there's a question about like anyone can interpret a clearly defined structure. The next question is just like, is there a library that does it? And then the next question is it easy to use? So next thing though, YAML. YAML is a much newer interface called YAML Ain't Markup Language. It's a funny little name, I guess. That is basically a popular modern format due to its ease of editing and concise nature. It's really easy to convert between them online. So what I mean by that is if we go and grab our JSON here, right, and then I go say JSON to YAML, we will very quickly see that. Why did it scroll me so far down? Just give me the darn page. Was that an ad or something? No. If I paste that there and I go JSON to YAML, oh, syntax error. Oh, it's the screwed up one. Sorry, I meant to, might take it off the slides. Because the slide had like the full version of it. There we go, that's what I want. Bam, there's the YAML. Okay, so why did YAML get created? It's a pretty similar thing to JSON. It's kind of the same scope, strings, numbers, arrays, objects. But it was basically literally, probably as far as I know, it was literally invented because people were kind of getting sick of things like the package.jsons just having a lot of cruff in there. Like there's like braces everywhere and stuff like this. And someone was like, there's just like a lot of extra characters. There's a lot of extra things to read. So why don't we just do it like that? Like people will figure it out. Now, I think the plus side of YAML is that it's a lot more concise if you understand YAML. I think the downside of YAML is it's a little bit harder to make sense of out of the box. You kind of have to work with it a little bit. But you'll see a lot of, I wonder if you can do it. npm package YAML. Do they do it yet? I don't think so. Package.yaml. Maybe it's only JSON. Yeah, I don't think so. But there are other things that you'll talk about next week with Yuchao where you will see some kind of situations where we use YAML. I don't think there's any I could show you right now that would make a great deal of sense really quickly. But the point is, it's much more concise. Unlike JavaScript, indentation does matter, which makes sense because they've basically been able to remove braces and square brackets and stuff by replacing it with indentation, right? Python has a very similar thing. Like Python compared to JavaScript looks a little cleaner, but they've done that because they've made indentation matter. A dash is used to begin a list item. It's very common for configuration files, and I think this is really critical because JSON became really popular as a way to transfer stuff, and it still is kind of the king of transferring things. So you want to transfer from program A to program B, you'll typically use JSON. YAML became a lot more popular for things like the package.json, where people aren't really trying to transfer information. They're just trying to store things in a simple configuration file that can be easily interpreted by a language, right? So what I mean by that is I made that example about YouTube. YouTube is probably not going to be sending much information as YAML because it's hard to package it up when it's white space sensitive. But for things like this, like a file, that's probably becoming more commonly YAML. And a lot of things will allow you to do JSON or YAML these days is what you'll see. But that's what YAML looks like. I don't really need to unpack it because there's a literal one-to-one conversion to JSON, and you could just sit down in your spare time and kind of like go through the details. The last one that's worth talking about is XML. XML stands for Extensible Markup Language. This was kind of the OG of standard interfaces for data transfer on the web in particular. It's generally considered a legacy format that's used less and less. You might come across it on the internet, but it's just a precursor to kind of JSON and YAML and stuff like that. It was a really simple format. It was kind of like a watered down version of HTML with like looking like HTML tags. But the reason it wasn't that popular is because it's more verbose. It's harder to read at a glance, right? Because there's a lot more stuff there. It's kind of like the absolute opposite of YAML. It's also more demanding to process or interpret because it's got more bytes as well, right? Like if you think about how much information is there, like if I just as an example, let's say I take that and I paste that in a file called blah.xml, and then I go and get the YAML equivalent here, blah.yaml, right? And then we just go and have a look at their file sizes, right? Like this, like the XML file is over 3 times bigger for that particular thing. So that also means it's going to be slower to transfer. It's going to mean like naturally anything that's big is a little harder to read. There's not really many benefits of XML. I'd say the only benefit I've seen to XML is that XML has the ability to say, for instance, add properties here, like to say, what's a good example? Suburb. This is not really the best data for it. Maybe let's say that there's something else here that's like, what was it? Suburb postcode country. I don't know. Type equals developed Australia. But that's also not really critical because the other way you can get around that is just by saying like country like this, and then inside that having more stuff and being like, name is Australia and like type is developed, So like, it's not like some unique feature that you can't solve by other ways. But beyond that, I've never really seen something in XML that's uniquely better. So there are just kind of generally downsides to it. So it is used less and less, but you will still see it around because it was used for quite a while as a reliable interchange format. And that's it for us today. I know there was 3 lectures listed today on the course website, but there was a very slim chance we were going to get through all 3. So UChao is going to continue through the rest because we normally can only get through 2 lectures per 2-hour block. But regardless, I hope you've had fun. I hope that was interesting for you. And we've learned a lot about data interchange formats, or in the previous lecture, jest testing. If you do have any questions, always feel free to post on the forum. There's lots of lovely tutors that'll help you out. Otherwise, you can also pop into help sessions and go from there. So thank you, everyone.